So let's start the session. It's almost 2 o'clock. So let's start the topic. Since we finished with integration, so now we are jumping into what? Partial derivatives, and then I'll teach you all to how to do the multiple integrals also. So now we are jumping into the second part. Okay. The last part is very, very small. It's only 2 topics. What is the Taylor series and this thing, beta and gamma functions. Okay. So write down partial derivatives. Now guys, what is the definition of a normal derivative? Do you remember? Don't write it down. Let me remind you. What is the normal definition of derivative? Dy by dx was what? Right? This is the normal differentiation that you have done here. Now this is applicable for a single variable function. That is, the variable here is only one, which is independent, which is that x. Now when you deal in multiple variable function, let's say I am defining a function known as u is equal to function of x comma y. And there is no other relationship explaining the connection between x and y. I just only know that u is a function of what? X comma y. Now the normal derivative idea is very dangerous. Why? There is variation in x, there is also variation in y. So how are we going to adapt the normal derivative definitions in this particular scenario? This is where partial derivatives comes into picture. Partial derivative says that, let's say I am taking partial derivative of dou u by dou x. What I am taking is partial derivative with respect to dou u by dou x. So if I want to write the definition of this, it will go something like this. Limit delta x tends to 0. Delta x is that incremental value h. Instead of h, I am taking what the value? Delta x. Where I am going to provide the increment? Only in the delta x part or only in the x part. Y part I keep as it is. I don't change the y part. I change which part? I provide increment only in the x part. This is what a partial derivative looks like. Minus the original function. What is the original function? Whole divided by what? But this is not the only partial derivative that I can do. Here I have taken the variable x. I can also do the same logic with variable y also. So if I do the logic with variable y, dou u by dou y will be what then, guys? Limit incremental value delta y tending to 0. Here where I am going to provide infinitesimal on which variable? Y variable. I am not going to change the x variable. So f of x comma y plus delta y minus the original function f of x comma y divided by what? Understood? So this is what is a partial derivative. So in partial derivative, why do we say is partial derivatives? I am only into providing incremental on one particular variable. So this is kind of like your normal derivative, but applied in a partial manner because there are more than one independent variables. There are how many independent variables? More than one. That's why we had to change the idea here. Understood how the behavior is working? Like that, you can go for higher orders also. In higher orders, you start to come across some weird things. Something like this. Dou square u by dou x square. What is this dou square u by dou x square? It is dou by dou x into then there is second order of dou square u by dou y square. What is that? Now comes the tricky term. Have you heard about this? What is this idea? Now, how to read this is, see the upper part, upper function. Let's start with the first function. Here, what is the rightmost thing? Y. So, how it is written is, interpreted is, That is, take the function u, take partial derivative with respect to y, whatever function that you get, that take partial derivative with respect to x. Now, is that possible? Here, is dou u by dou x function of x or function of y, or is function of x and y? It's function of x comma y. I have subtracted the function, but I have not eliminated the y. Did I make y is equal to 0, by which I completely remove the y out? No, I didn't do that. This is just an incremental subtraction. It does not remove the y out. So it's still a function of what? Some other function of, not, let us call that f bar of x comma y. This is some other function of x comma y. So both the variables are still present here. They are not getting eliminated. The only way to eliminate is if I assign y is equal to 0, then only I can eliminate it. I am not assigning y is equal to 0. I am still keeping the variable. I am taking subtraction between functions, not between variables. Understand the part here? So similarly, that dou u by dou y, that next part, this is also a function of what? X and y. This will also have a variables of what? Whatever function that you get will be what? X comma y. So even higher derivatives will be functions of x comma y. Any doubt here? The only difference here in the bottom part is, here rightmost is dou x, na? So it is dou by dou y into any issue here? So this is what your second order derivative. Then there are third order. Don't go. Third order is not that much needed. Is this okay? Okay. Now, other thing that you need to learn in partial derivative is known as a concept known as Euler's homogeneous theorem. Right. Euler's homogeneous function. There's a special application on Euler's homogeneous function. This is generally also called as Euler's theorem. Okay, same thing. But it is mainly Euler's theorem. When I generally refer it, there are a lot of Euler's theorems. So in which context here you're talking, you must always be able to tell it. So yeah, I'm talking here in which context? Homogeneous function concepts. So what is the homogeneous function? Not necessarily. Right side equal to 0 does not make it a homogeneous function. Yeah, I discussed this earlier, right? Okay, let me show you an examples of some homogeneous function. Let's say f of x comma y. Tell me whether is it homogeneous or not. So what is a simple way to check homogeneous is, check each and every term. Let's start with x cube term. What is the degree of x cube term? 3. What is the degree of x square y term? Now x square has a degree 2, y has a degree 1. If it's multiplied, add up the degrees, because multiplying power becomes adding, na? So 2 plus 1 is what degree? 3. So x square y together is degree 3. X square y together is degree what? 3. What is the y cube degree? 3. So if added or subtracted terms have same degree, then they are homogeneous function. Another way, now tell me, is this homogeneous or not? Is this homogeneous or not? See, What did I told you regarding homogeneous function? For algebraic functions, added or subtracted terms must have same degree. So let's individually see. In the numerator, who are the added and subtracted terms? These are all the added and subtracted terms. What is the degree of each and every term? Here also, this is the added term. Again, the degrees are same. This is division. Na? Did I say anything regarding division? Division degree can be different. Added or subtracted terms should have same degree. Okay. So for algebraic function, what is the logic? Added or subtracted terms should have same degree. Now, if I take this entire function together, what is the entire degree of the function? How to do that is, what is the degree of the numerator? 3. Denominator degree is 4. So division means powerly what happens? 3 minus 4, which is what? What is the degree of this entire function? Which was 3. What's the idea? So this is how we understand homogeneous function in which function case? Algebraic. This is regarding only algebraic. For non-algebraic function, it must be of the form it must be of what form? F of y by x. Let's see. Is this homogeneous? Because sine y by x does not have a degree, right? So still homogeneous. What did I say? If there is non-algebraic part coming, it should be acting as what? Y by x function. So this is y by x function. So sine y by x is homogeneous. It is multiplied by xy. What is the degree of xy? 2. What is the degree of x square? 2. What is the degree of denominator? Is there any issue? This is purely homogeneous functions. Again, is this homogeneous? Is this homogeneous? The answer is yes. Why? Now, guys, sometimes you may think that the inside part is homogeneous. Agreed. But log function game, so it should be whether it is homogeneous or not, we have to check it out. So how to check it out is, what did I say regarding non-algebraic function? It should be coming as a part of what? Y by x. So if it's directly y by x, then no issue. If it's not y by x, try to convert into that. So how to convert this into y by x idea is, take x cube common in the numerator and x cube common in the denominator. So if I take it, what will happen? If I take x cube common, what is that? Similarly, in the denominator, if I take x cube common, what will happen? 1 plus y by x plus y cube by, what is happening to x cube and x cube? So this is entirely purely log of some y by x function. All I'm going to get is what? Got it? So this can be converted to y by x idea. Got it? Why this is homogeneous? But if they were of different degree, na, this would not have been homogeneous. Why? If let's say after taking common x cube and s cube, let's say some x is remaining, that will have a degree. Na, that is not y by x. If the numerator and denominator were of different degree, then I cannot say that this is homogeneous. Why? Because that x cube will not cancel completely out. Some x will remain either in the numerator or denominator. That will have a degree, na? And that is not y by x portion. So that's why this will become a non-homogeneous function. So you have to be very careful in how to interpret homogeneous function. Now guys, what is the benefit of homogeneous function is, every homogeneous function will always pass through origin. Geometrically speaking, every homogeneous function will always what? Pass through the origin. What's it out? Clear? Every non-homogeneous function will pass through origin, but the vice versa is not true. Every equation passing through origin is not homogeneous. The classic example of that, I think so, discussed in my metrics class. Y square is equal to 4x, parabola equation. Y square is equal to what? 4ax. It's actually passing through origin, but not a homogeneous equation. Because what is the degree of y square? 2. What is the 4x degree? 4a is constant, x degree is what? So is this a homogeneous function? The answer is no. Clear? So what is the benefit of homogeneous function? It always pass through origin. Okay. Now what Euler observed in homogeneous function is, he realized that if I do this kind of an integral, this kind of a derivative, x, the answer is n times of u, where n is the degree of the homogeneous equation. Where n is what? N is degree of the homogeneous equation. X dou u by dou x plus y dou u by dou y will be this value. This is what is taught in your textbooks. For gate, we have to go one more step. Is it taught in your textbooks? Yes. No need of derivation. For gate examination, no need of derivation. In your that is BTech life, what they ask is, check whether homogeneous equation are valid. So you have to write down this equation and then left hand side and right hand side you have to equate it. Those kind of questions cannot be asked in your gate examinations. So I'm not going to cover those questions. So this is the equation up to second degree. Can actually go for higher degrees also. How to generate for the third degree? Or how to generate for the third x cube? Did you see the coefficients? What are the coefficients? X plus y the whole square, na? So for the third order, how will you generate? X cube dou cube u by dou x cube plus 3x square y into dou cube u by dou x square y plus 3x y square into dou cube u by dou x y square plus y cube into dou cube u by dou y cube is equals to n into n minus 1 into n minus 2 into u. Like that, you can go for the higher powers. For gate examination, only 2 powers are needed. I told you how to generate it, but for gate examination, this is sufficient. This is the theorem. Now, Euler's theorem can also be extended for 3 variable functions also. Okay, it can be like this. If u is this f of x comma y comma z is a homogeneous function of degree n, then x dou u by dou x plus y dou u by dou y plus how many variables are here? 3 variables, na? So z dou u by dou z will be what? Now second order is very lengthy. What is x plus y plus z the whole square? X square plus y square plus z square plus 2xy plus 2yz plus 2zx. Like that you will write it. It will be a very lengthy left hand side. So not even asked. First order is sufficient for 3 variables. Okay, so this is what is your Euler's theorem looks like. But you will also have to learn the modifications of Euler's, and those are written as corollary. Right? Whenever you hear the term corollary, means it's a same rule but modified in some other way. Write down corollary. COROLLORY. COROLLORY. Double LORY. Corollary. Okay, let's start. Okay. So it goes something like this. If u is equal to f of x comma y, if u is equal to f of x comma y is not a homogeneous function, is not a homogeneous function, but capital F of u, is a homogeneous function. What is the classic example of this is, let's say I give a function like this. Is this homogeneous? Is this homogeneous? Yes or no? Obviously, since I'm giving this under this, then obviously it is not a homogeneous function. Why is it not homogeneous? I discussed this idea also. If I try to convert this into y by x, what will happen? I have to take x cube common in the numerator. 1 plus y cube by, what happens in the denominator? What is the resulting function now? Now think about this. If I split this function out, since this is multiplied and all these things, if I split it out, log of x square plus log of what? 1 plus y cube by x cube minus log of 1 plus y by x. I can write like this, right? Multiplied, I can write it as plus. Log of ab is log a plus log b, right? You know that property, right? And log of a divided by b is what? Log of a minus. So this is homogeneous. This is homogeneous. What about this? Is this homogeneous? This is where we are going to stuck. That's the reason why this function is technically what? Not a homogeneous. But if I remove this log function and take it on the other side, and if I define like this, e raised to u is equals to, now e raised to u is homogeneous, huh? Because when I take e on the other side, this is purely algebraic function on the right hand side. For algebraic function, degree should not be the same in the numerator and denominator, right? Only for non-algebraic, I have to convert this into y by x. For algebraic, I don't have to do that. So this is homogeneous now. Understood? This is the scenario that we are discussing in the condition, in that corollary. So u is not homogeneous, but the other function of u, which is e raised to u, that is homogeneous. Understood the scenario? What we are trying to say here? Okay, if that is the case, what he says is, then write down, then x dou u by dou x, sorry, x dou u by dou x plus y dou u by dou y equal to n times of f of u divided by f dash of u. N times of f of u divided by what? F dash of u. Okay, is that okay? Any issues? So all you have to do is what? The f of u. What is f of u here? In this particular case, what is that f of u function? E raised to u. So e raised to u divided by derivative of e raised to u. What is derivative of e raised to u with respect to u? E raised to u itself. So you'll get the answer as n. Find whatever. What is the degree of n? What is the degree of the right hand side? 2. Numerator 3, denominator 1. So total degree is you have to subtract 3 by 1. Na? So what is the total degree? 2. So the answer of what the idea? But this can also be extended to higher order. So let's also learn that also. Now for higher order, what I'm going to do is I'm going to assume this as g of u. Write down this n f of u is take that as g of u. Okay. Now what is g of u? N f of u by f dash of u. Okay. For second order, you have to take that function and multiply by the derivative of that function minus 1. So what is g of u? Please note it down. N f of u divided by f dash of u. N f of u divided by what? F dash of u. That is your g of u function. That should be taken for second order. Quite easy, right? Corollary 1. Next, corollary number 2. Corollary number 2. There are two corollaries. Write like this. If u is equals to f of x comma y, if u, let us write like this, right? U is equal to f of x comma y. U is a function which is combination of two functions. What are those? One is f of x comma y, other is g of x comma y. Where write down f and g are two separate homogeneous functions. Where f and g are two separate homogeneous functions of degrees m comma n. Of degrees what? M comma n. Now tell me, f of x comma y is homogeneous, g of x comma y is homogeneous. Now tell me, is u homogeneous? Is u homogeneous? The answer is maybe, may not be. When is it homogeneous? Is when m and n are equal. When m and n both powers are equal, they are homogeneous. But if m and n are not equal, then they are not homogeneous. So we are going to, if this is homogeneous, we already have the proof for that. What is that? You use your conventional Euler's theorem. But if it's not a equal case, let's work for that. So write down in bracket m not equal to n. And if m is equal to n, we already have the original theorem, right? Why we have to do this corollary? So we are focusing on which corollary? When m is not equal to n. So obviously u here is right now not homogeneous. Then the rule goes like this: x dou u by dou x plus y dou u by dou y is equals to, what is the order of f? What is the order of f? M. So m into f of x comma y. What is the order of g? N. So n into g of x comma y. We want a second order version of this: x square into dou square u by dou x square plus 2xy into what? Dou square u by dou x dou y plus y square into dou square u by what? Dou y square equal to, how will it will operate? M into m minus 1 into the function f plus n into n minus 1 into function what? This g is a function, okay? If you want, write like this. This is what is Euler's theorem all about. These are the statements and their corollaries. So this Euler's theorem can be extended to these two types also. I showed you the original Euler's theorem for 2 variables and 3 variables. Guys, most probably you are going to face is 3 variables. And worst case scenario for your respective subjects, you are going to face is 4 variables. What are those? For EC and electrical, you have the variables known as X, Y, Z, T, EMT, electromagnetic theory. Computer science, no need. You people are not even learning that. For other branches, EC and electrical, you have the variable X, Y, Z, T in EMT. For mechanical and civil, you again have the variable X, Y, Z, T in fluid mechanics, heat transfer. Okay, so those again will come into picture. So there is 4 variables there. Okay, so understood this idea? No issues with this. Next thing, write down. Total differentiation. Total differentiation. Now let's understand, let's develop the total differentiation for 2 variables. Then I can show you how to go for higher variables also. Let's say I have a situation in which u is equals to f of x comma y. Now guys, how to write a differential of this? Differentiation, not differentiation. You have to write the differential of this. That is, okay. So for partial derivatives, the way of writing the differential is, or you can leave out this du. You can write like this also. This is how a differential is written down. Du is equal to what? Dou u by dou x into dx plus dou u by dou y into what? Dy. Now guys, if I want to extend this further into total differentiation, What is total differentiation is finding du by dx, not dou u by dou x, du by dx. We sometimes write in textbooks as capital du by capital dx. That is what is known as total differentiation. How to approach this is, the only way to do that is I also need one more thing, the connection between x and y. So without knowing that, I cannot do this further. Got the idea? So if further it's given that, let's say y is some function of another variable known as t, x is some function of another variable, the same, another function but of the same variable t. Okay. If I want to find du by dt, what is that? Dou u by dou x dot dx by dt plus dou u by dou y dot. Now sometimes what happens is, there are other times when directly y and x are connected. Directly what are connected? Y and x. So if y is directly a function of u, y is some other function, let us call this g of x. If y is what? G of x. In that scenario, how will you operate this? Finish writing this. Can I go to the next page? Finish writing. Please write it. So, if I directly take du by dx, what will happen? Dou u by dou x into dx by dx. What is dx by dx? 1. So, no need of writing that. Plus dou u by dou y into what? There are other versions also. Du by dy also can be found out. How? You can take derivative as dy by dx, or you can also take derivative as dx by dy. You just have to redefine the function. Generally, you define the function as y is equal to f of x. You redefine the function as x equal to f of y. And then you do the dx by dy derivative. So you can substitute that. What the idea? So how to approach each and everything. So you just have to modify it accordingly, whatever is required. Next, this same idea can also be extended to chain rule in partial derivatives. Chain rule in partial derivatives. So how does chain rule in partial derivative works? Let's say if u is a function of what? Original definition, x comma y. Same logic is here. But x is another function of g1 of, let's say, r and s, and y is another g2 of r comma s. So u is a function of x comma y. R and y are individually functions of what? X comma y, and x and y are individually functions of what? R and s. So in that case, how will you operate? So what did I write regarding du? What did I write regarding du? Dou u by dou x dot dou x plus dou u by dou y dot. Just see here, this thing. This same term, if you want to write it du, you can also write it dou u also. That is, if I write dou u, now which do you want, r or s? Which variable do you want? Which variable do you want? Let's start with r. If you want s, Now, if R and S are further function, we can extend it further also. So this is a chain rule idea in partial derivatives. So this is chain rule, na? When is chain rule used? Function of functions, na? You use a function of x comma y. X comma y is are separately functions of what? R comma S. So same differential idea. If you understand that differential idea, na, that can be used for any number of variables also. Okay. The same idea is used in your EMT. Same idea is used in fluid mechanics. For mechanical, another subject is also there known as heat transfer. There the same idea works into picture. Any doubt? Understood how the one single idea can be modified with different ways. This is what is total derivatives and its associated partial rule. Is this much okay? Just focus on partial derivatives up to this topic. Okay. Next, you have to learn is the application of this. There is only one application you need to focus, then that is maxima and minima. Write down maxima and minima. In partial derivatives, one and only one application you need to focus, that is maxima and what? Minima. Now, guys, when you go for maxima minima, the topics restricted for you is only for 2 independent variables, not for 3 independent variables. So just stick to what? How many independent variables? 2. So let's start. So let the function be what? Let u is equals to f of x comma y. So how many independent variables? 2. Now I am defining some terms, or I am assigning some terms. Dou u by dou x I am calling that as p. Dou u by dou x I am calling that as p. Dou u by dou y q. Dou square u by dou x square I am calling that as r. Dou square u by dou x dou y I am calling that as s. Dou square u by dou y square I am calling that as t. Okay, I'm just redefining it and just calling some terms so that my representation is very good. Okay, otherwise if I go for the partial derivative definition, the representation is very bad, so you won't be able to follow it. So to make it simple, I'm just assigning some values p, q, r, s, t. Now, guys, do you remember what did we say for partial derivative? For maximum minimum? That's for single variables. How do you start the procedure? You start with the first derivative and equate that to 0. Here, how many first derivatives are there? So the first procedure is p equal to, find p. You have to find obviously p. Then p equal to 0 and q equal to 0. R is second derivative. Who are the first derivatives here? P and q. So p equal to 0 and q equal to 0. You have to solve this. Solve this and find the values of x and y. Solve to find values as some points. Here the points will be not single value of x, but x comma y. Here the values will be in which form? X comma y. It will be a point, right? So it will be x comma y. So these are what your first order equal to 0 and getting the answer. What that point is called as? Critical point. What is that known as? Critical point. So this is the location of critical point. Next you have to find out is, you have to generate a term known as s square minus rt. And another term is needed, r. 2 terms are needed. S square minus rt, r. What is s square minus rt? You can see here. What is s square minus rt? S is this term, r is this term, t is this term. So accordingly, find out the values of this. And then what? Substitute the critical points. and substitute what? The critical points. Okay. So this much is a procedure. Now I'm going to write down the conditions. So write down conditions. Write down. If S square minus RT, first condition, if S square minus RT is less than 0 and R is also less than 0 and R is less than 0, then point is maximum. You remember, right? Whenever there is less than 0, you define that as maximum. So the same logic. If S square minus RT is less than 0 and R is also less than 0, then point is maximum. Write down. Second condition. If S square minus RT is less than 0 and R is greater than 0. If S square minus RT is less than 0, but R is what? Greater than 0, then the point is minimum. Okay, so S square for maxima or minima, S square minus RT should always be less than 0. The R is defining term. If R is less than 0, it is maxima. R is greater than 0, it is minima. Understood? S square minus RT must always be less than 0. Next, third criteria. If S square minus RT is greater than 0, then the point is saddle point. Point is saddle point. S square minus RT is greater than 0, then the point is what? Saddle point. And there is one more criteria. If S square minus RT is equal to 0, if S square minus RT is equal to 0, then the point is indeterminate. Then the point is indeterminate. You cannot investigate that point. Understood how to approach this? And now in some textbooks, instead of S square minus RT, it is written as RT minus S square. So there the logic will completely change. If you are taking RT minus S square, instead of less than 0, what will you write? Wherever there is less than 0, write greater than 0, and wherever there is less than 0, greater than 0, write that as less than 0. Okay, the entire logic will change. That's it. You can use either one of them, but stick to one. I prefer always S square minus RT. That's my preference. If what you have learned is RT minus S square, then stick to that also. No issues with that. Okay. So understood the criteria? This much is your partial derivative. That's it. Let's do some problems on this. Okay, this function. This function is not clear. Write down. First question number 1. Function is x square y. Write down f of x comma y is x square y minus 3xy plus 2y plus x. X square y minus what? 3xy plus 2y plus what? X. You have to find the answer for this. Can you start? X square y minus what? Then? Okay, let's start. What is P? Derivative with first derivative with respect to x. What is first derivative? So how to take first derivative is, when you're taking derivative with respect to x, assume y as a constant. Treat y as a constant. Whatever you do for constant, treat the y as that. So y is a constant, so x square derivative is what? 2. 2x into y, so 2xy. Here again 3y is constant. What is the derivative of x? 1. So the answer is minus 3y. What is derivative of 2y alone? 0. Plus derivative of x is, so this is your p. Next is q. What is q? Dou u by dou y. So I have to take x as, I have to assume x variable as constant, treat the y variable. So x square into derivative of y is 1, so x square just. Next, 3x is constant, derivative of y is again 1, so minus 3x and plus 2. That's it. X derivative is 0. So the first process is what? Take this value is equal to what? Now how to solve this is I always solve this simultaneously. That is, I draw a line, side by side I solve it. So 2xy minus 3y plus 1 equal to 0, obviously. This is what? X square minus 3x plus 2 equal to 0. From this, what are the points that I'm going to get? So x equal to 2, x equal to 1. What about here? How can I solve this? Huh? So the only way I can do it is once I get this, substitute this here. Substitute this points here. So if I put x equal to 2, what is the value that I get? 2 into 2y minus 3y. I'm putting x equal to 2. So 4y minus 3y plus 1 equal to 0. So this is y. So y is equal to what? Minus 1. That's one point. If I put x equal to 1, what will happen? If I put x equal to 1, what will happen? 2y minus 3y plus 1 equal to 0. So that is y equal to what? What did I say regarding points of this thing? That is, critical points that occur here are always pair of x comma y. Na? So how is the x comma y pair going to come? If x is 2, what is the value of y? Minus 1. If x is 1, what is the value of y? So the points are like this. So the points are like this. Any doubts here? Okay. Now, in the question, actually, how many extremas are there is asked, but we have to find which is maximum, which is minimum. Now, what is S? S is what? And how to take S is? S is dou square e by dou x square. Na? We already have dou u by dou x, this function. Take the derivative of that function with respect to x. So take p's derivative with respect to x, partial derivative obviously. So what is that going to be? Just 2y. Right? What is r? Sorry. Sorry. R, my mistake. I made a mistake. R. R is take the derivative of u and take with respect to x. So take p, take the derivative with respect to x. So what is that going to be? 2y. S, my mistake was, S is actually dou square u by dou x dou y. So what you have to do is, you already have p function. There are two ways of approaching this. You can take p and take derivative with respect to y, or you can take q and take derivative with respect to x. Either of them follow. So what I prefer is I want to take p and derivative with respect to y now. So if I take derivative with respect to y, I will get 2x minus, and I am taking derivative of this with respect to y. So 2x is constant, derivative of y is what? 3y, 3, that is y derivative 1, so remaining 3. So that's how I get 2x minus 3. Now what is t? Dou square u by dou y square. So what is dou u by dou x? This dou u by dou y, this one. Take again derivative with respect to y. So what is that? There is no y function, so what is s square minus rt? R and T, the product is 0, na? So just 2x minus 3. Now put your, in 2x minus 3 only x values are there. So put the values of x. So at x equal to 2, what is s square minus RT? What is s square minus RT at x equal to 2? 1, so obviously greater than 0. Next, s square minus RT for x equal to what? 1. What is the value? Again 1. So again greater than 0. So both are which points? Both are saddle points. So write down, there are, both are saddle points. So what is the correct answer to this function? Let me show the options. Let's discuss the options now. That's the tricky part here. What are the options? No local extrema, one local maxima but no local minima, one local minima but no local maxima, one local minimum and one local maximum. Which is the correct option? No local. Saddle points may be local maxima or minima, but it's not a sure shot thing. Saddle points may be local maxima minima, but it's not a guaranteed logic. It's not always that. So we cannot thoroughly say that that is the answer. So the only conclusion which is correctly possible is no local extremas. Are you getting my point here? So the correct answer is no local extremas to this particular function. Again, let me repeat. Yesterday when I talked it, I said that saddle points can be a local maxima or minima, but it's not a guaranteed thing. So you have to come to, whenever you come to a conclusion, you have to be very careful that conclusion is always true. Those conclusions only you can accept. You cannot even accept a partial conclusion. Next. Okay. This is a theory question. Tell me answer of this. Question number 27. Tell me the answer of this. The continuous f of x comma y is said to be a saddle point at a comma b if, what is the condition? Can you read it? Let me zoom in further. F of x a comma b is equal to f of y a comma b is 0. That is true, right? F of f square x comma y, what is that? S square, right? F of x comma y is f of f suffix x comma x xy is what? Dou f by dou square f by dou x dou y. Let me repeat. F square suffix x comma y means what? It's a function of dou square u by dou x dou y. What is that function? S square. F suffix xx means what? Dou square u by dou x square. Fyy means dou square u by dou y square. So s square minus rt less than 0 means it's not a saddle point. When it becomes a saddle point, s square minus rt greater than 0. So which function gives you s square minus rt greater than 0? Got the idea? This is the actual representation. Do you like this? That's why I gave you PQRST. Understood why I changed my notations? This is the actual notation. It's quite weird to learn this. Okay, most of the students may not remember it. So that's why I just changed my notations to PQRST. Even in your textbooks also that same notations are used. PQRST. It's not I changed, someone else changed to that simplicity. Is it clear? Next. Yeah, this question 48. Question 48. Find P, find Q. Please find that. Let me do it. P is what? Take the derivative with respect to x. So if I take the derivative with respect to x, what I'm going to get? 2x square derivative is 4x plus 2y. That's it. What I do is I write side by side. Q. What is Q? 2x minus 3y square. Okay, let's start with this function. So 4x plus 2y is equal to 0. Okay. Sorry guys, I didn't read the options correctly. You don't have to find the points. The point is already given in the option. You have to just investigate at the one particular point known as 0, 0. You don't have to find all the extremas and everything. You just have to investigate at which point? 0, 0, because it's quite tedious to solve it. Because one is y square and it's quite very difficult to solve it. It's not that easy. Okay, so just find it at which point? 0, 0. So now let's directly jump to R. What is R going to be? Take the derivative of P with respect to X. What is that? 4. S is what? 2. T is what? Take this derivative with respect to Y. So minus. So now S square minus RT. What is that? What is S2? So 4 minus 4 into minus 6y. So if you simplify it, you will get the answer as 4 plus 24y. Now, since the point is 0, 0, when I put that in S square minus RT, what is the answer? S square minus RT is 4, na? So it is greater than 0. So what is this point? Saddle point. If S square minus RT is greater than 0, then there is no need of investigating R. You don't have to waste time in investigating what? R. Only if it is less than 0, then only investigate for R. Clear? So this is what point? What is the option? What is the option? But there is an option 1, minus 1. Na? In option C, you can see there is another point. 1, let's investigate that also. So put a 1, minus 1 in S square minus RT. Please do that. Yeah, same. Huh? Why substituting in P? No. What about saddle? It will still be 0 in P. Saddle point will be 0 in P. It doesn't tell you. Only in second derivative it distinguishes you which is the correct point. P just gives you which are the critical points. It doesn't tell you which is maximum, which is minimum, which is saddle point, which is indeterminate. Only second derivative will tell that. Okay, there is one more point, 1, minus 1. Let's check that. 0 comma 0 is not a saddle. 0 comma 0 is a saddle point. That is clear, right? Let's investigate 1 comma minus 1. So if I put 1 comma minus 1, what happens? S square minus RT is minus 20. Oh, it's less than 0. If S square minus RT is less than 0, then next investigation should be R. R is what? Whatever be the function, R is always greater than 0. So what is the case? 1 comma minus 1 is a which point? Minima. Write down. 1 comma minus 1 is the minima. 1 comma minus 1 is the minima. Now that is an extrema. So how many stationary points? Okay. Now guys, 1 maxima, 1 saddle. But always remember, saddle point, maxima points, minima points are all critical points. So from the option, the only conclusion I can come is 0 comma 0 is a stationary point, 1 comma minus 1 is also a stationary point because they both are critical points. Okay, there is one more point, 1 by 6 minus 1 by 3. Okay. Sorry. I have to change the method. There's a small issue. We just have to investigate saddle stationary points now. Okay. Let me do one thing. Instead of focusing on the options now, that's where I made a mistake. Instead of focusing on the options, let me start with the question itself. Then we got P and Q. Let's try to solve it out. What I did is I took 4x on the other side and then divided by 2. Okay, so I get y is equal to what? Minus 2x. I will take y is equal to minus 2x and substitute in this function. So 2x I keep it like that. Wherever there is y, I will replace that by what? Minus 2x. So minus 3 into. So what is the function that I get? 2x minus 2x plus 3 into 2 6 x square. 6 2 into 2 4. 4 into 3 minus 12 x square equal to 0. If I take 2x common, what is the function that I get? 1 minus 6x. So there are two options: x is equal to 0 or y is x is equal to x is equal to 0 or x equal to 1 by 6. I'm showing you how to solve this. It was a tedious method, so I went for options, but the options are becoming very tedious, so I completely changed the method now. So this is okay. Now, this is just x value. I need also the y value. So take these values and substitute in y. So what is the y value? When I put x equal to 0, y is also 0. When I put x equal to 1 by 6, what is the y? Now, what did I say regarding the points that we select normally? Points should always be a pair. So first, when x is 0, what is the value of y? So that is the first pair. Next point. When x is what? 1 by 6. Nah? What is the y value? That is the second pair. So we are getting only 2 pairs. So these are the 2 critical points. Now they are not asking you to further investigate whether it is maximum or minimum. Stop here. They are just asking you who are the critical points. That's it. So understood how to solve the equations? So what you have to do is take one equation, substitute in the other. So how to substitute that is convert into one variable. There was 2x plus 4y, na? So I converted that into y is equal to something like that. And from there I substitute in the other equation, I get a quadratic equation. From there I solve it out. Always remember, one equation variable is only easier to solve. Otherwise, it's very difficult. So that's why we do this kind of a stuff. It's not that easy. Sometimes the functions may get complicated. If it is able to avoid, I avoid it. But here I was not able to avoid it. Okay. So the correct answer is what? Which option? Option B has two stationary points at 0, 0 and 1 by 6, minus 1 by 3. Okay. Whether they are maximum minima, we cannot say it. We have to investigate that. We investigate 0, 0, right? 0, 0 was found out to be what? Saddle point. We can also investigate 1 by 6, minus 1 by 3, and that can be minima. See, saddle point, maxima, minima, even indeterminate are all what? Critical points. Other name of critical points is stationary point. All these things are critical. Critical and stationary are one and the same. Next. Yeah, do this question 61. Question 61. So let's read the function. F is what? 0 x raised to n plus a1 x raised to n minus 1 y plus dot 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 plus a raised to a n minus 1 x into y raised to n minus 1 plus a n y raised to n. What is this term actually? This is some part of binomial expansion. A plus b whole raised to n. Do you remember that? But it's not perfectly binomial expansion because there are some combination terms coming into picture. NC0, NC1 like that. Forget it. Tell me whether this is homogeneous or not. Is it a homogeneous function or not? What is the degree of a0 x raised to n? A0 is constant. So what is the degree of x raised to n? N. A1 x raised to n minus 1 y. That is the next plus term. What is the degree of that? N. So like that, if you check each and every degree, each and every term, the degree will always be n. So write down, this is f is homogeneous function of degree what? N. This is the main part you have to recollect. If degree is n, homogeneous, I can directly apply Euler's theorem. So how I came to the conclusion that Euler's theorem must be asked? Do you see the expression that is asked here? This is something similar to Euler's, right? X dou u by dou x plus y dou u by dou y. So what is the answer of this? N times of u. So here instead of u, what is the function? F. So n times of f. That's it. So this is what? N times of f. So question number 61 is direct application of Euler's theorem. Yeah, actually this I forgot to do. Please see this question. Which one of the following graphs, question number 169. Which of the following graphs describe the function? The function is given as f of x is what? Question number 169, okay. F of x is what? E raised to minus x into, what is the function? X square plus which option will be satisfying this function? Okay, it's quite easy, but you will have to investigate it based on the max and minima. So let's understand this. Tell me first derivative. What is the first derivative of this? So obviously I have to do the product rule, right? So what is the product rule? E raised to minus x into what is the derivative x square plus x plus 1? 2x plus x square plus x plus 1 into derivative of e raised to x. E raised to minus x is what? E raised to minus x. Yeah. Now take e raised to minus x as common. Okay, so here this minus into x square is minus x square. Minus x plus 2x, what is that? Plus x. And then there is a term known as minus 1. This is what is a derivative function. Now by seeing the graph, at least you can come to one conclusion. X values are all greater than 0. Right? All of the values in all the graphs, x values are all greater than 0. Right? So x value is greater than 0 means this is only lying in the positive domain. Okay. Huh? Oh, cancel. Okay, now let's understand this case. Let's put this condition. So I'm trying to find the maximum minima in the conditions. So I'm assuming to find maximum minima, what is the criteria? Take first derivative, equate that to 0. So e raised to minus x into what? Minus x square plus x. And now will e raised to minus x be 0? Only way it can be 0 is when x is infinity. That is not allowed. We cannot take x equal to infinity. So e raised to minus x is technically never going to be 0. So the only term that is going to be 0 is this bracket. So therefore we realize minus x square plus x can be 0. So x, if I take common, what do I get? Minus x plus 1 equal to 0. So x is equal to 0 or x equal to 1. These are the two possibilities of which point? Critical points. These are the two possible critical points. Is that okay? Now let's find out whether it is maximum or minimum. So how to check that is take second derivative. This is not a partial derivative function because this is not a multiple variable. This is single variable. So just take the normal second derivative. What is second derivative? What is the original function? Yeah. Take the product rule of this. So e raised to minus x into minus x square plus x derivative is what? Then plus minus x square plus x into derivative of e raised to minus x is minus e raised to minus x. Again, e raised to minus x can be taken as common. Let's start. Minus x square. Then minus 2x plus x square, sorry. Because this minus and this minus gets multiplied. Then minus 2x minus x. What is minus 2x minus x? Minus 3x. Then 1 will remain as it is. Okay, start. F double dash of 2, what is the value? For f double dash of 0. If I put 0, what is the value? E raised to 0 is 1. This is 0, this is 0, this is 1. So 1 into 1 is what? It is greater than 0. So x is equal to 0 is what? Minima. Next, f double dash of, let me do it here. F double dash of, what is that other point? 1. If I put 1, e raised to minus 1 into 1 square, 1 minus 3 plus 1. What is that? Minus e, or minus 1 by e technically. Equal to, this is minus 1 divided by e. E raised to minus 1 is 1 by e, na? Inside the bracket there is minus 1. So this is technically less than 0. So x equal to 1 is what? Okay. Once you get this, Now this can be used as a guidance to understand whether it is going to, how to behave. So 1 is minima, 0 is minima, 1 is what? Maxima. So if this is minima and 1 is maxima, that is if the function is traveling from 0 to 1, whether the function should be decreasing or increasing? Increasing. Then only it can reach from minima to maxima. Right? So from 0 to 1 function should be seen as increasing. After that function should, since this is maxima, after 1 the function should then decrease. So just see which condition satisfies that. Which diagram satisfies that? Only option B. Option A starts with a higher value and then it's just continuously decreasing. Option C, the problem is there are many saddle points between that. So option C cannot be accepted. Option D's problem is what? Again, same. It's starting from maxima and going to minima. So at 1 it is almost like minima. We are getting the opposite of that. At x is 0 is minima and then we are getting maxima. So which is the option which satisfies this? So this is how this is the reason why I am giving you all the geometrical explanation. That is, you must relate to geometry. Then only you will understand increasing, decreasing idea. This was asked for EC branch. EC branch calculus questions are slightly tougher. The branch which faces the toughest question in a calculus topic is EC branch. Branch which faces the easiest question in calculus is, I think so, production engineering. No one is there. Others are kind of like middle of that. The branch which faces the toughest question in this is EC. And electrical also. EC electrical same level. There is not much of a difference in paper. Level of paper is almost same.